Statics is a branch of mechanics that has to do with forces, vectors, moment, among others. In this video, we are going to consider the difference between scalar and vector quantities. We will also consider how we can resolve forces acting at a point. Then we will solve this question as you are seeing. Then we'll also consider how we can find the resultant of forces and consider forces in equilibrium. We will also solve this question as you are seeing. So let us begin. So we begin with the difference between scalar and vector quantities. We know scalar quantities have size only. They do not have direction. Vector quantities have both magnitude or size and direction. Examples of scalar quantities include mass, temperature, time, length or distance, speed, energy, displacement, velocity, force, acceleration, momentum are also examples of vector quantities. Now let's consider coplanar forces acting at a point. Coplanar means in the same plane or of the same plane. So we are going to see how we can resolve forces acting at a point in the same plane. Now we have a force here. Let's call it F. Now this force F, to resolve this force means we want to find the vertical and the horizontal component of the force. So for this video lesson, we are going to consider the direction of the force measured from the vertical axis up to the force. So let's call this the theta. So this is our theta. Then we have a horizontal component of the force F, and we also have a vertical component of the force F. Now, this horizontal component of the force, let's call it F sub x. It will be equal to the magnitude of the force times sine theta. How do we get that? Because by trigonometry, sine theta will be equal to F sub x over magnitude of F, which is the hypotenuse. So this will be the right angle will be here. So that will give us the horizontal component of the force will be magnitude of F sine theta. Similarly, we can find the vertical component of the force to be magnitude of F cos theta. So when we resolve the force F, we will obtain it in the component form as magnitude of F sine theta, then magnitude of F cos theta. Remember, the theta is measured from the vertical axis, or let's say from the north pole. Now let us see how we can solve a question with this. A hot air balloon is traveling at a velocity of 10 meters per second at an angle of 60.0 degrees up from the horizontal. Find the horizontal and vertical component of its velocity. So remember, velocity is vector quantity. So let's have a diagram like this. So this is our velocity. The magnitude is 10.0 meters per second. So that's the velocity. So it has a horizontal component here, and it also has a vertical component. So we are trying to find those forces, the horizontal component and the vertical component. And we're given the angle that the angle is 60 degrees up from the horizontal. So this angle is 60.0 degrees. But our theta is the angle here. So that will be 30.0 degrees. So the vertical component v sub x will be equal to 10 sine 30.0 degrees. And that will be equal to 5 meters per second. Then the vertical component will be equal to 10 cos 30.0 degrees, and that will be equal to 5 root 3 meters per second, or 8.7 meters per second. Now let us look at equilibrium of particles. When forces are in equilibrium, their resultant will be equal to 0. That is, the net force will be 0. So our objective here is to find the resultant of forces. Then we'll also consider when they are in equilibrium. So we have two forces here placed head to tail. So the head of this force is at the tail of this force. So let's call this one F1 and let's call this one F2. Now we can have a third force that is meeting F1 and F2. So that third force is what we call the resultant force. So the resultant force will be equal to the sum of the two forces F1 plus F2. So we must first of all resolve the F1 and F2 into their component form. Then we add the corresponding components. So we can see that these form a parallelogram. They are all meeting the resultant here. So some call it the parallelogram law of vector addition or addition of forces. We can also have the polygon law. So with the polygon law, we have more than two forces. So F1 here, F2 here, F3 here, F4. They are all meeting this force here, which is the resultant. So the resultant will be equal to F1 plus F2 plus F3 plus F4. So as many forces as we have, we add them. That will give us the resultant of the forces. And if they are in equilibrium, then the resultant will be equal to 0. That's the zero force. Now let us look at an example here. Two children are pulling on a toy. The forces exerted on the toy are shown below. We are to calculate the resultant force, including the angle at which it acts to the horizontal on the toy. So how do we solve this? We can resolve the forces. So let's do that. Measuring from the knot, we meet this force at 270 plus 40. From here to here is 270, and from here is 40. So that will be 310 degrees. And remember, the force is given by magnitude of the force sine theta and magnitude of the force cos theta. And the theta here is the one we measured up to this. So that will be 310 in this case, 310 degrees. So let's call this our first force F1 and call this one our second force F2. So F1 will be equal to 22, which is the magnitude of the force sine 310 and sine 310. Then we have 22 cos 310. So we need to simplify this. So 22 sine 310 will give us negative 16.85. Negative 16.85. Then we have 14.14. Then F2, we repeat the same process. We measure from here until we meet the first here. So this is 90 plus 50. So our theta is 140 and the magnitude of the force is 18. So 18 sine 140. 18 sine 140. Then we have 18 cos 140. So they are in degrees. So F2 will be equal to 11.57, 11.57 and negative 13.79 newtons. Now we are to find the resultant. So the resultant will be the addition of the two forces. So R will be equal to F1 plus F2. So that will be equal to negative 16.85, then 14.14. We add it to 11.57, then negative 13.79. Negative 13.79. And when we simplify this, it will give us negative 5.28 and 0.35. So that will give us a force in the third quadrant. So a force in the third quadrant. Because, so this will be R. This will be negative 5.28, which tells us the direction. The negative tells us the direction. Then we have 0.35 here. So to find the angle that is making with the horizontal, we have to use trigonometry. So let's call this alpha. So tan alpha will be equal to opposite, which is 0.35 over adjacent, which is 5.28. So alpha will be equal to tan inverse of 0.35 over 5.28. Remember, the negative here is just for direction. And when we simplify this, we will get 3.82 degrees. We could also find the magnitude of the resultant force. R will be equal to the square root of negative 5.28 squared plus 0.35 squared. And this will simplify to 5.29 newtons. Let's have another example on equilibrium of forces. A particle is at rest, so it means it's in equilibrium because the net force will be zero when it is at rest. The particle is at rest under the action of three forces, two of which are P 4 Newton and 30 degrees, then Q 10 Newton and 300 degrees. We should find the third force. So let the third force be S. Then adding P to Q to S, we have to get the zero vector. So we need to resolve the forces. So P will be 4 sine 30 degrees and 4 cos 30 degrees. Then Q will be 10 sine 300 degrees and 10 cos 300 degrees. Plus S, the force we are finding, the third force. And this will give us 0, 0. So the 0 vector has component 0, 0. So 4 sine 30 is 2. And 4 cos 30 is 3.46. Then 10 sine 300 is negative 8.67. Then we have 5 for 10 cos 300 plus S is equal to 0, 0. So S will be equal to 0, 0 minus negative 6.67, then 8.46. Because this and this will give us 8.46. This and this will give us negative 6 points. So when we simplify this, we are going to get 6.67 and negative 8.46. So that is the third force. Then we need to convert this to magnitude and direction form. So we need to find the magnitude and direction of the force 6.67, negative 8.46. So the magnitude is given by square root of 6.67 squared plus negative 8.46 squared. And that will give us 10.77 newtons. Then we need to find the direction. So the direction, the force will be in this quadrant here. So we are finding this angle because we had negative 8.46, which is somewhere here. Then we had 6.67, which is somewhere here. So when we trace this, we have 8.46 here. So the angle here, let it be alpha. Tan alpha will be equal to opposite, which is 8.46 over 6.67. So alpha will be equal to tan inverse of 8.46 over 6.67, and that is giving us 51.75 degrees. So we need to add this to 90. So plus 90, that will give us the direction. Therefore, the force S should be 10.77 Newton to 2 decimal places, and the direction will be 141.75 degrees.